Unit 4 test review, it's a doozy, so let's go. In an inverse variation, now remember the book says y equals k over x, but I like to just think of it, multiply both sides by x. One number times another number will give you that consistent product. So this is what I tend to use. So it says x is 2, y is -4, that's k, which is -8. And I kind of have fun with that. That's the constant, spelled it wrong, product. So it says, what's the value of y? So they're like, use that formula when x is 16. So 16 times y has to equal my constant product. I divide by 16, divide by 16, so y is equal to -1/2. Shouldn't be too bad. Number 2, b varies inversely with x. So they're just adding or throwing different letters at you. So, I mean, technically, I could throw in the letter y if that helps your brain, and then you can use the same formula. But really, so I'm going to stick with that. So they're saying, go ahead and use this, or use this. And I'm just going to put y's in for the b's. So, if b is 1/2, or excuse me, if y is 1/12 and x is 6, so that's 6 times 1/12 equals k. If I do the math, that turns into 6/12 or 1/2 equals k. What's the value of x when y is 2? So x times y has to equal k because it's a constant product. And now I could divide by 2, but I can see over here that might be confusing, so I'm going to multiply by 1/2. It's the same thing. So I get x is 1/4. So it's just kind of simple algebra if you can keep it simple in your head. Graph the function 5 over x. What is the domain, range, and asymptotes of the function? So remember, our parent function is y equals 1 over x. Remember, our go-to locator point should be 1, 1, -1, 1. We should also know that the y-axis and the x-axis are already asymptotes. So if I go 1, 1, -1, -1, and just remember the asymptote rule, it should look something like that. It's not a 90-degree angle, is it, Jack? And so then we go like that and like that. So there's our parent function. Now this right here is a very strange thing, because if I was to actually plug that in, and these being our locator points, if I plug 1 in for x, that would actually be 5. And essentially if I just kept going, 2 would be 5 over 2, or 2.5. If I put a 3 in, I'd get 1 2/3, which is 1.6. Put a 4 in, I'd get 1.25. Put a 5 in, and I'd get 1. So really, if you look at this, 1, 5 would be right 1, 2, 3, 4, 5. I'm going to use it, well, we'll stick with it. 2, 2.5. You can kind of see where this is going. 3, 1.6, 4, 1.25, 5, 1, and you can see that essentially, like we talked about in class, it moves the vertical stretch part of that simply, or not so simply, moves that curve in. And we're going to kind of duplicate it over here, move it in, and then redraw it, and it kind of goes like that. Okay, now we got to talk. I'm going to highlight this in yellow, and I'm going to highlight that in yellow. So that's what we're focusing on. What's the domain? Well, because we've got this asymptote, which is x equals 0, which means x can't equal 0 in that function because it put a 0 in the denominator, we know that the domain has two chunks. This goes to the left forever, so it's negative infinity all the way up to 0. It's trying to get to 0, but it can't. It's got another part. Starts out, how far left does this yellow guy go? Well, it tries to get to 0, but it can't ever touch it, and then it goes to the right forever. Now what's the range? Well, we start here in this piece. How low does it go? Negative infinity. How high does it go? Well, because this is the horizontal asymptote, it's trying to get up to 0, but it can't. And then that's together with this piece. This thing gets as low as 0, but it doesn't touch it, and then it goes up forever. And the asymptotes, well, the yellow one we already talked about is x equals 0. And then the orange one right there is y equals 0. That's the other asymptote. And there you go. Here we go. Describe how 5 over that has been transformed. It says describe. It doesn't say graph. So what does that do? Well, based on our rules, it moves it right 3. What does that do? Up 4. And because that's a 5 and that's a 5, there's no change in the vertical stretch. It doesn't move at all. So it says write the equation of a function has been shifted left 2 and up 3 for the given parent function. So that right there, left 2 is going to be taken care of down there. Up 3 is just going to be added 3. So what's my answer? Y equals 1 over x plus 2 plus 3. And that's the adjustments to the parent function. All right, number 5. The volume of a gas varies inversely with pressure P. So that means V times P equals K. Now it says if the volume of the gas is 6 with the pressure 25, let's just find out what K is right now. That's 150. That's what equals K. That's the key to this whole problem. What is the volume? In other words, V times P equals K. What is the volume of the gas with the pressure 15? So if that's 15, we're trying to find the volume. We know our K is 150. Divide by 15, divide by 15. The volume would be 10. And there it is. Okay, number 6. Identify the vertical. All right, vertical. Where we're going to get that? Right here. We're going to try to talk about what x cannot be. So we're going to factor this. So 2 factors of 14 that add up to 9, 7, and 2. So because x cannot equal negative 7, my vertical asymptote is x equals negative 7. Whoa. X plus 2. And because x cannot be negative 2, x equals negative 2. Now the horizontal asymptotes, if we remember our rules, if the top degree is less than the bottom, that's the rule for the horizontal asymptote, and that's what we have right here. We got a 1 and we got a 2. And so the rule for that is your horizontal asymptote will be y equals 0 for the horizontal asymptote. Doesn't say simplify, so don't factor, factor. They're just straightforward questions. So they're kind of messing with you now. We've got this situation. We're going to go ahead and talk about the horizontal first. We take a look at our degrees. That's a 2, that's a 4. And as you can see, the top is less than the bottom again. So we're going to have y equals 0. But now we got to focus on this crazy denominator right here. They're messing with you big time. But that's no different than, well, it's a difficult version of a difference of 2 squares, because that will turn into x squared minus 25 and x squared plus 25. And this guy expands to x minus 5, x plus 5. Now you could spend the rest of your life trying to factor that, and that's impossible. So this clearly, right here, x cannot be a 5, so x equals 5 is one of our vertical asymptotes. X can't be negative 5, so x is negative 5 is another one. This would create imaginary numbers. Let me prove it to you. If I said, let's find out what causes that to be a 0, I would go x squared equals negative 25, bada boom, bada bing, do the right thing. I'd get plus or minus 5i. These are not real numbers, so they don't create real asymptotes, and that would get the job done. And here we go. And I also I went to Desmos because I wanted to see how crazy that was, and you can check it out yourself, but that is definitely one of your horizontal asymptotes, and these are your verticals. So let's go on. All right, so once again, the top degree, we don't care about that 2. The top degree is less than the bottom degree. That's consistent. So y equals 0 is our horizontal asymptote. Vertical, we got to look here. Tricky one now. We got a negative 6. So, but we need a positive 5. So that'd be plus 6 and minus 1. So x cannot equal negative 6, so our asymptote is x equals negative 6. X cannot equal 1, so x equals 1. There's our vertical asymptotes. Finally, we got one that's a little different. The top degree equals the bottom degree. That's where, for our horizontal asymptote, that's where we reduce. Now, we don't reduce the whole thing. You just reduce the top degree term and the bottom degree term. There's an invisible 1 there, so these cancel. So that means my horizontal asymptote is y equals 16. Now to find the vertical asymptotes, you got to factor the bottom here, so that'd be minus 8 plus 2. So x cannot equal 8, so that's our vertical asymptote, or negative 2. So there's our vertical asymptotes. There's our horizontal asymptote. Now a graphing section. Graph each function. Well, remember, this goes back to 1 over x, 1, 1, negative 1, negative 1. You just got to know those locator points for the parent function, and that's how you get started. Now, we know this is going to, let's go ahead and just do that first. It's going to move it in. I'm not going to be too particular about that, but that's our next step. That's kind of the vertical stretch of this whole thing. And now I'm going to move that, our last thing, everything. Now I'm going to go ahead, recognize that that's an asymptote and that's an asymptote. I got to move everything right 3 up 2. So I'm going to focus on the center. Right 3 up 2. That's our new vertical asymptote. There's our new horizontal asymptote. And then just do your best job kind of duplicating our previous drawing. So right about here, kind of guessing. There you go. So the horizontal asymptote is right here. That's up 2, so it's y equals 2. Vertical asymptote is right 3, so it's x equals 3. All right. This guy. So we look at this, they're taking it to the next level, they're saying graph it. Of course you can use your graphing calculator. We're going to try not to do that, but we got this guy right here. That's x plus 1, x plus 1. So as you can see, x equals negative 1 is going to be our vertical asymptote. So we're going to go left 1, I'm going to draw it in pencil, kind of scary. There's our vertical asymptote. Now notice the top degree equals the bottom degree, so that means we're going to reduce. So 2x squared all over x squared, there's an invisible 1 there, these go bye-bye. So y equals 2 is our horizontal asymptote, so that's up here. Now give me 2 seconds. All right, and then if we just remember our parent function, y equals 1 over x, we can kind of slide this in. That 2 would probably create a little bit of a vertical stretch, so it comes in a little bit, but not a ton. Not going to worry about it too much. And then it would be right here, so I'll just kind of fall short of that, and then slide the rest of that in like that. So there you go. All right, let's try this one. Once again, 1, 1, negative 1, negative 1. You got to start with the parent function. Hopefully you're getting that good and memorized. And now that moves it in a bit, right to there-ish, and ish. And now we got to move everything right to. So once again, I'm going to start here, and I got to move that right to, and that's it. So that moves right to, this stays, and you try to duplicate that drawing. I'll use my green marker, kind of like that, and like that. A lot of ish there. We graphed it. That right there is y equals 0. That's our horizontal. That right there is our vertical. X equals 2 because it moved right to. All right. Last one, going to be a little interesting here. Again, let's get the parent function on the board because everything depends on your ability to know that. Looks like there's a heavy emphasis of this. So if you notice, this is a 1 and this is a 1. So what we're going to have here is, as far as the horizontal asymptote is, we're going to reduce. So we're going to go 1x to the first, that's what this is, over negative 2x to the first. These reduce, so I end up with y equals negative 1/2. Now, it's going to be tough to draw, but we're going to try it. So we're now going to go right here, right down the middle, and this guy is actually, give me 1 second, if we take a look at this, we got to find out what value for x causes this whole thing to be 0. So this guy, negative 2x minus 6 equals 0. If I add 6 to both sides, divide by negative 2, I get x is negative 3. That's our new horizontal. I'm just going to use orange. X is negative 3, so 1, 2, 3. And there it is. Now, give me 2 seconds. So, I just wanted to focus on something here. Not sure how you want to look at it. But if I take a look at that, remember, if I have y equals 1 over x, that would look, well, that would look like this and like this. I'll just draw it right in here. But if I throw a negative, remember, 1 over, if I throw a negative in the top, it's the same thing as throwing a negative in the bottom, which is the same thing as throwing a negative out in the front. Now, if you notice, our leading coefficient has a negative in front of it in the bottom. So it's like having a negative down here. If you wanted to get really fancy, you could take a negative out of this and go 2x plus 6, and then that negative would come upstairs, if you want to think of it that way. My point is, this negative is going to flip this graph over the x-axis. So this would turn into this would turn into that. So that negative, I would, let's see what color I'm going to use. I'm going to use yellow and kind of come in like that and like that. So that's just moving it. And now we have to make the adjustment, and with the grand finale with the negative there is to flip this over the x-axis. So this portion is going to be like that. This portion over the x-axis will be like that. So my green stuff is my final answer. That's a doozy. Okay, so I'm going to try to finish this, and then that'll be part 1. But this says, find the simplified product. That means multiplication, pretty self-explanatory. State the domain. The domain is before you cancel things. So what we're going to do is we're going to immediately take a look at this. Factor, 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 hector, hector, hector. That right there is x plus 4, x minus 3. This right here is x minus 3, x plus 2. And there's an x plus 2. I'm going to put that in parentheses. I'm going to put that in parentheses because it kind of compartmentalizes things for you. Now is the time to find the domain. X cannot equal 3 because that would cause that to be a 0. Negative 2 because that would cause that to be a 0. And negative 4. So that's how you talk the domain talk. Now we're going to simplify. X plus 4's go away. X plus 2's go away. And these go away. What am I left with? Nothing? No, these all reduce to 1. So it's like a 1 and 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 a 1. So we multiply it, we just get 1. Let's go on to this guy. Last problem for this video. So take an x out, because that's all you can do, x plus 8. This guy, I'm going to do my work here. I'm going to take an x out of each one of these because I can. X squared plus 5x minus 24. Now that's going to turn into this. X plus 8, x minus 3 times, now we got some work to do here. So I'm going to take an x out of that. I'd be left with x squared plus 2x minus 15. And that's in the top. So that'd be x times x plus 5, x minus 3, all over 1. Find the domain now. So because I can't have a 0 in the denominator, x cannot equal 0, cannot equal negative 8, cannot equal 3. Now we can start canceling things. So those x's go bye-bye, those go bye-bye, these go bye-bye. The only thing left is x times x plus 5. That'd be your answer. That finishes part 1.